Hello, everybody. My name is Jared Spitzmacher. I'm from the University of Calgary in Alberta, Canada. I'm joined today by Amanda Neves, a research associate as well. So we'll be found at the booth over there today. First, just want to thank organizers for having us today. I appreciate it. I know you guys are kind of over time right now, so I'll try as fast as I can. I appreciate your time here today as well. I'm here to talk to you about FaceBase project and briefly discuss how we are compiling a robust database of three-dimensional scans of the face. And specifically, we're focusing on rare craniofacial syndromes that are known to affect craniofacial shape and how we are developing a clinical tool that can help physicians in diagnosing such syndromes in the future. So what do I mean when I use the term FaceBase? Essentially, what I'm referring to is actually both the database and the attached website where researchers, not just a public website, where researchers around the country are brought together by their shared interest in studying facial development and facial characteristics. This platform allows researchers to securely upload data from their own projects to the repository, which is actually kept and maintained by the National Institute of Dental and Craniofacial Research, part of the NIH. Human data, however, is not available to just anyone. Only those researchers who have been approved by a selection committee are eligible to access such records. So the goal of our project is to use 3D photography and other technologies developed in the past decade to turn the analysis of facial attributes into a science instead of an art. Some of these technologies include vastly improved analysis of complex 3D shapes, such as the face, validated statistical methods that can process various components of shape variation, and impressive advances in 3D imaging systems. The first step of our research study is to build a library of 3D facial scans associated with specific genetic syndromes, such as Prader-Willi. We currently have representation from hundreds of different genetic syndromes in our library, and we continue to grow this daily, actually. We have teams around North America. I'm from, like I said, Calgary, and we do have teams in Denver and San Francisco as well. Once we get sufficient amount of data, then we can now move on to the design stage and produce a prototype diagnostic tool, and then scientists and physicians can use this in their own clinics. So for our study, if you would like to participate, obviously beforehand, any questions you have about the project, either here today if you want to answer after this session, or obviously throughout the day, we'll be here till the end here. I can answer those questions for you. I want to give you a full understanding of the study before you do enroll. Normally, we do try and employ a reservation-based system, but with the numbers today, I think anytime you guys want to come on by, just come see me. We can definitely get that done right away, probably. It's kind of one of those things where the paperwork does take longer than the actual process to take the picture, so we can swing on by. In order to participate in the study, basic consent form that describes the study, lists the benefits and risks of the study, and also what to expect. We do ask for some medical information about yourself and ask that you sign a medical release form so that we can obtain a copy of your diagnoses and medical records. This will enable us to accurately associate your facial scan with the correct diagnosis in our database. Once all that's done there, the fun part is actually starts. It's a 3D picture. As you can see on the right-hand side there, actually in the next, you'll see in the next slide there, there's a camera and a camera that I have associated or set up over here on the side. It's actually quite the contraption. And it's essentially a 2D flash photography. It's not like an intensive scan or anything like that. It's a 3D white flash camera. And it's really quick. It's a quick flash, and obviously I can show you yourself in 3D right away if you'd like as well on the computer. So obviously too, in a database, we're going to make sure you're de-identified, so your information, your name, is going to be removed. The only information that we're going to have is like your date of birth, your head circumference, weight, height. That's all going to be included in the database. And then we also give you a unique string of numbers and letters. So when we do upload our data to the hub, is what we call it, you will be accessed by other researchers as well. We kind of employ the data sharing principle where this information is going to be used by other approved researchers. So again, that's not going to be just anybody accessing the website. That human data side of everything is going to be really secure and obviously only accessible by those that are selected by the committee. So this is the camera on the right-hand side that I was trying to show you guys there, in the red there. So it's got the arms out there. And it's just going to take a picture like a white flash a white flash camera, like a 2D image. It's from 3D EMD, the company that we've been with for a few years now. It's kind of like a passport picture. It's going to be a neutral face, nice and relaxed, no glasses, hair tucked behind the head. And then that's when we do kind of randomize the letters and numbers to you, and you kind of de-identify yourself before entering the database. Lastly here, so after I do take that 3D photo, again, what we do there is we do take out the hair, we do take away all that information that we don't want. We just want the shape of the face, so we crop all the rest out. We do place landmarks on the face, so around the nose, the eyes, the chin. We get we get different dimensions of the face essentially in a 3D space. And then what we do is we analyze the 3D images of the patients with specific known syndromes to define features characteristic to each one. So we do look at ones individually. For example, Prader-Willi, we will obviously look separate from everyone else. And then once we define those models for each condition, we combine it to a diagnostic tool. And then we're going to develop methods that physicians can use essentially to differentiate between the ones that are included in the database for us. Study contact information, these are the 4 main individuals who run the project. So out of Denver, San Francisco, and then obviously University of Calgary, where I'm from there. Their information there. It's also on all of our material as well that we have handing out today. Yeah, that's all I really have for you today. Once again, thank you for having us. We have to take questions at this time. Yes.
So for your facial neuroven, jaw distraction, are you tracking a child who had jaw distraction? Does it grow or change differently?
Yeah, so on the forms, yeah, if there's any kind of surgeries or any kind of alterations of the facial shape that may affect the natural shape, we definitely ask that you do report that, and then we'll try and correct it for in the data. So, oh.
Hi. When our daughter was first diagnosed, one of the physicians looked at her face and saw that she had olive-shaped eyes.
Okay.
And then a month later, after some genetic testing, we found out she had Prader-Willi syndrome. That same doctor who did the genetic testing on our daughter 4 or 5 years later missed the Prader-Willi diagnosis, the same neurologist. So, but the first doctor who saw the olive-shaped eyes, we took note of that comment he made, and so I could see how your project here would benefit other people.
Mm-hmm. Yeah, I've been hearing that a lot too with individuals that are syndrome. They're very similar, and that's where that fine kind of quantitative analysis with the 3D shape can help differentiate between those two, and hopefully we get a diagnosis earlier than you would instead of going between.
Yeah, so it was just one doctor that made he must have seen it before, but it got missed. You know, some of these diagnoses get missed.
Mm-hmm. Well, thank you for your comment.
All right.
Awesome. Thank you.